Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 11, Factoring Expressions. And before we jump into this, one of the first things we want to look at as we factor expressions, basically we're kind of pulling apart expressions, putting them back together in a way that makes more sense and it's maybe a little bit easier. We're going to be using greatest common factor and the distributive property to write equivalent expressions. So real quick, as we're going to jump into factoring expressions, we need to know what those two things are. So the distributive property is this. If we have a problem 5h, 5 times h, plus 5k, or 5 times k, I can factor that out and know that basically since you're multiplying both of these by 5, we can have h plus k, and we can have 5 over here, meaning that 5 would be distributed. 5 would be you'd multiply 5 times h and by k. So that is distributive property. Now, for greatest common factor, again, just as a quick review, if we're going to find the greatest common factor of, let's say, 12 and 9, well, we're going to look at 9 and 12, and we're going to write the factors, right? So the factors that go into 9 would be 1, 3, and 9. Factors that go into 12 would be 1, 2, 3, 4, and 6, and 12, I guess. The ones that they have in common would be 3, 1, but you can't use 1 because that doesn't change anything. So it would be 3. So the greatest common factor of 12 and 9 would be 3. That's just a little bit of a review on that. So let's jump into a couple of examples, because I think this is the kind of thing that as you see it, you'll start to understand how we're going to use it. Okay, if you look at this example, it has variables. We have A, B, and B, and they're being put together. So we can say that that's addition, right? But if we want to break this down, we could say that A and A is 2A, right? It's A 2 times. B and B would then be 2B. So you could look at it as A plus B plus B, or you could look at it as 2 times A plus 2 times B. Two different ways of looking at it. They're equivalent. You're going to get the same answer. We can rewrite that same tape diagram. We can look at 2A, 2B, and we can say, well, we have an A plus a B, and then we have another A plus another B, and we could put A, B, so that you have these two together. And then if we're going to use the distributive property, well, how many A's are in the expression? There's 2 A's. How many B's? There's 2 B's. So we could say it's A plus B plus A plus B, or we could then use the distributive property since we have 2 A's and 2 B's, and we could say it's 2 times A plus B, because we do have A plus B 2 times. So we've now factored that expression. We've used the distributive property to make it a little bit easier. Okay, let's look at another example. Okay, we have 3F plus 3G. This is 3 times F. This is 3 times G. So if we're taking F plus G, and we're really thinking about it, 3 is being multiplied by both. So we can put F plus G in parentheses and use the distributive property and have 3 times F plus G. Here's another problem. 6x plus 9y. Now we're going to use our greatest common factor, because looking at these two, I know that 3 goes into both numbers. And so I can then factor out the 3, and we can say 3 times, and then 3 goes into 6 twice. So we have 2x plus 3 goes into 9 3 times 3y. So we end up with 3 times the sum of 2x and 3y. Okay, let's look at a little bit of a different problem. Here we have 3 times c plus 11 times c. Now, there is a common factor. The common factor isn't with the numbers, though. It's the fact that you have two c's. So you can factor out the c's then, since it's c times 3 and c times 11. You're multiplying both numbers by c anyway and adding them. So you can take the c out, factor it out, and have c times 3 plus 11. You could also say c times 14, or 14c. This is kind of what we're looking at as far as the factorization that'll go. As far as the factorization goes, though, but I did want to just show you these other two options here. Okay, 24b plus 8. Well, I know that 8 goes into 24 and 8 goes into 8, so that has to be the greatest common factor because 8 is the greatest common factor of 8. So if I divide that by 8, I can put 8 on the outside. 8 goes into 24 3 times, so we have 3b, plus 8 goes into 8 one time. 8 times the sum of 3b and 1. All right, 7x plus 7y. Hopefully you're seeing that, hey, there's two. They both have a factor of 7, so I can take the 7, put it on the outside. X plus y on the inside of the parentheses. Because you're multiplying both of them by 7 anyway, so why write it twice? Put it on the outside. You've got a factorization. You've got distributive property, so it works. Go for it. One last example here. I know I'm going through these fairly quickly, but I just want you to have some examples to look through as we work on these together, and then you can always go back and check these out. So, 15 and 20. I want to find the greatest common factor, right? I'm going to make a little factor tree here, a factor rainbow. 1 goes into 15, 3, 5, and 15, right? 1 times 15, 3 times 5. 20, I'm looking at, of course, 1 and 20. I'm looking at 2 and 10. I'm looking at 4 and 5. And there I go. So now I can divide both by 5 because that's my greatest common factor. So I'll put 5 on the outside of the parentheses. 5 goes into 15 3 times, 3g, plus 5 goes into 24 times, 4h. Distributive property helped me write an equivalent expression. This expression is equivalent to this expression, right? You're going to get the same answer either way. Okay, let's do one more example, and let's actually do one where I give you the variable amounts. So we have 6x plus 21y. But now I'm telling you x equals 3 and y equals 4. So I'm going to rewrite those with those factors. I have 6x, except x is 3, plus 21y, except I know y is 4. So I have 6 times 3 is 18, plus 21 times 4 is 84. 18 plus 84 is 102. Okay, I know I've given you, like I said, a lot of examples. You can go back and look at these. You can check them. You can check your work with these examples. We'll talk more about this in class, but I wanted you to just have several examples similar to what you'll be seeing that you can go back and check out. So, thank you for watching. We'll talk more about this face-to-face, and I'll see you soon.